there. That doesn't look too bad.
Okay, so the problem was 2x minus 3y equals 8 and negative 4x plus 5y equals 10. You have to use elimination because every variable has a coefficient in front of it. And I decided to multiply the top equation by 2 to get the x's eliminated. And when you multiply it by 2, you get 4x minus 6y equals 16. And then when you combine the y's and the other numbers, you get negative y equals positive 6. And then simplified is y equals negative 6. And then I plugged in negative 6 into the top equation again to solve for x, and I got 2x minus 3 times negative 6 equals 8, which equals to 2x plus 18 equals 8. And then when you subtract 18 and divide by 2, you get x equals negative 5, y equals negative 6, and the ordered pair is negative 5, negative 6.
Any questions with 21? Rebecca, why didn't you want to use substitution?
Because every variable has a coefficient in front of it.
Awesome. Good answer. Nice job. Very nice. Where's our cheering section, Matt? Thanks, Matt. Melanie, you have that black thing, push it towards the classroom. There you go.
So I did 31, and so I multiplied the bottom equation by 2 because all the variables had a coefficient, and then whenever you multiplied it, you got negative 4x plus 10y equals negative 18, and then whenever you add them vertically, you get 0 plus 0 equals 0, and that simplifies to 0 equals 0, and so you get infinite solutions.
Can you keep that there?
Oh,
You
yeah.
don't have to stand up there, but I just want to talk about the answer on it. For number 40 or 31, she ended up with 0 equals 0, and that means there are infinitely many solutions, Melanie, because what kind of lines would they be if you graph them?
The exact.
Yeah, they're the exact same line if you graph them. So 0 equals 0 is a true statement. It's allowed to happen. It just means that if you were graphing these, getting them in y equals form, you'd end up with the same line. So when you have a 0 equals 0 in like the algebra process, that means you have infinitely many solutions. How would you know if they're parallel lines and you have no solutions, like when you're solving a problem like this? What would it look like if there's supposed to be no solution? Odette? Yeah, so it would be an untrue answer. So if you ended up canceling these and you might get like 0 equals 3, if the answer is not true, 0 does not equal 3, not even on a Friday, that's when the lines would be parallel and there would be no solution. So 0 equals 0 is okay. If you got that and you were worried that you did something wrong, that is actually part of the solution. It happens every once in a while because we can have that case where we have one line graphed on top of the other. But when they're parallel lines, your answer, especially if you use elimination, like all the variables still cancel out, but the other side, you're going to have a number on the other side. So if your solution doesn't make sense, then there is no solution. It's not true. So I'd like you to look at number 47. Because we're going to go over number 47 with all those fractions. And I'm going to show you at least like maybe a slightly easier way to work through it. taking a peek at number 47. I believe there are 6 fractions. I think every part of that has a fraction. So we have 1/2 x, 2/3 y, and it's equal to 5/6. And then the second one has 5/12, 7/12, and it's equal to 3/4. So when fractions are in equations, there's a couple of different things that you could do with them. You could obviously keep them in the problem and get a common denominator so that you're dealing with, in the top, maybe all denominators of 6, and in the bottom, all denominators of 12. So you could definitely keep them and work through the problem involving the fractions. However, we can also get rid of them. So instead of keeping them in the problem, eliminate them like we kind of discussed in chapter 1. So if you look at the bottom of all 6, so look at it as an entire set of equations, one entire problem. What would the common denominator be of all 6 of those fractions? So if we just had all 6 lined up, Julie, what would the common denominator be? 12. So we're going to use the common denominator of 12 to get rid of the fractions instead of keep them in the problem. And to do that, we're going to multiply the entire first equation by that least common denominator of 12. And we can do that to the second one as well, multiply the entire second equation by the least common denominator of 12. Now, you have a calculator. So if you can't do the mental math, that's fine, but you're taking 12 times 1/2. So this 12, you're using the distributive property, just like the elimination process. So that's kind of what we're doing here, but we're multiplying by 12. So Julia, 12 times 1/2 is 12 times 2/3 is? Again, if you're not sure, mentally use the calculator. And then 12 times 5/6 becomes 10. So in one step, you had 3 fractions, and now we have 9. Which, even me, I like working with fractions, but I'd rather not use them in 5 different steps to solve a problem if I don't have to. So by using that least common denominator, we now have this new equation, 6x plus 8y equals 10. So then looking at the bottom part, doing the exact same thing, we have 12 times 5/12. Eric, do you know what 12 times 5/12 is? 5. 12 times 7/12 is? And then 12 times 3/4 would be? So fractions were there, now the fractions are gone. Like magic. Poof. Except that he did it algebraically, it wasn't technically magic. Questions? So now that they're not in the problem anymore, now you can just use the regular elimination process. So if you're looking at all of them, everything is positive. You have a 6 and a 5, you have an 8 and a 7, so you just kind of have to decide what do you want to multiply by to eliminate one of the variables, and it doesn't matter which one. But the elimination process probably works better here because all those variables have something in front of them. So Abby, what do you think? What could we multiply by? Okay, so top one by 5. And the bottom one by 6, or you can make it a -6 so that we have those opposite signs happening. So the top equation, multiplying it by 5, is now 30, 40, and 50. The bottom equation, -30, that's what we need to happen for elimination. Those two numbers need to be the same so that it can cancel. And then we have -42 and -54. So yes, the problem is a little more involved than just a typical problem that would start out without fractions, because you do have to do an extra step to get to the problem so they don't have fractions in them anymore. So Gavin, if we use elimination, combine these together, what is our resulting equation? So y is 2. I would suggest taking that 2 and plugging it back into one of the problems without a fraction, because you got rid of them. You don't want to take a 2 and plug it back into a problem with a whole bunch of fractions in it. I mean, unless you really wanted to, you could, but you probably want to work through one that doesn't have a fraction. So once you know y is 2, you can just use the first one, plugging in the 2, and then we would have 6x is equal to -6, so x is -1. So that same process you can use for 49, except 49, the first equation has the set of fractions, not all of them. But using the least common denominator eliminates the fractions from the problem. Any questions on that? I know it looks like daunting with all those fractions, but that would be an awesome honors level question on a test. Maybe not regular algebra 2. Honors, fair game. It's kind of what separates you. You get the more challenging problems. Same concepts, just a little more interesting. Questions? So in your notes, I want to just go through one problem in the notes, and it's the word problem that would be at the bottom of section 2.2. So it should say application. Bottom of page 11. So we'll skip the notes that are at the top of page 11. If you go to the bottom of page 11, so there was a word problem dealing with guitars, and it looked like all of you did pretty well with that word problem with the guitars. This one wants us to write a linear system and then solve it. To raise money for a new football uniforms, your school sells silk-screened T-shirts, which is pretty much what they do, I think, in graphics. Does anybody have graphics? They make the T-shirts up in the rotunda. So you design them, and then, like, literally you make them. I believe they're making T-shirts for the faculty next week. Anyway, short sleeve T-shirts cost $5 and are sold for $8. Long sleeve T-shirts cost the school $7 and are sold for $12 each. Your school spends a total of $2,500 on the T-shirt, sells them for $4,200. How many of the short sleeve T-shirts are sold? Write equations and then solve the system. Thanks. Does she hate me? Does she hate me? She was annoyed that you were sent up there late. Not really. So the first thing, we have a problem with variables, so let's label what those variables mean. Julian, what do you think we could call our x and y variables? Sure. So short sleeve and long sleeve. If you'd rather use an S and an L, feel free to use an S and an L. Alright, so read through the problem, see what 2 sets of equations you would create. So you need 2 equations to make it a system. So just kind of think of what information would be similar that you would group together in one equation. Kenzie Myers, what do you think?
Would you do 5x plus 7y equals 2,500?
And why'd you group that information together?
Because that's the amount of how much they spent.
Good. So all of these represent how much they paid for the shirts. So $5 for the short sleeve, $7 for the long sleeve. They spent a total of $2,500. So those would be considered like pieces. And then Mackenzie, the second equation would be
x plus 12y equals 4,200.
And that would be what they sold it for. So how they made money versus the money that they spent. So then you have to decide what you want to do to solve the problem. Holly, how do you think you'd solve this problem? Yeah, elimination probably would be best. We have 4 variables or 4 coefficients, different coefficients in front of those variables. What do you think we would multiply the first equation by? What could we multiply by? Kind of decide, do you want to get rid of x, do you want to get rid of y? Like that's your first step. X has smaller numbers in front of it than y does, so maybe you want to try and get rid of x. So what could we multiply by to make the x the same number? Mackenzie?
In the first one, you multiply it by 8, and the second one by -5.
Perfect. So often when you have the two numbers, if you just multiply them by each other, the top one by the number that's in the bottom equation, the bottom equation by the number that's in front of the x in the top, usually that works to help eliminate if you're not sure what numbers to use. So Mackenzie, if we do that, what does the new top equation become?
40x plus 56y equals
12,000.
20,000.
Oh, 20,000. Okay. There we go. Thanks, Connor. And then, do you have the new second equation too? What do you have?
Second equation is -40x minus 60y equals -21,000.
Nice job. Connor, we're at the bottom of page 11 in your packet. So I got some big numbers here. Combining the two equations together. What do we get? What's the resulting equation? So when you combine them together, what's that result, Emma, that you get with these two equations? And then Emma, y would be 250. Questions? So then you have your y, you want to plug the x back into either of those two equations so that we can find x. So plugging 250 in. And solving this, Emma, what did you get for x? Say it again. You're so quiet. 150, sorry. My ears aren't working very well this morning. So 150, we're selling 150 short sleeve and 250 long sleeve t-shirts. Make sure that when you have a word problem, you take that answer and you finalize it. So it's not just an ordered pair when it's a word problem, that ordered pair means something. So in this case, we have 150 short sleeve t-shirts and 250 long sleeve t-shirts. Questions? So it looks like there's almost 20 minutes, like 7:58, we end at 8:18, so about 20 minutes. I have a pair of worksheets that I'm going to pass out. Unfortunately, the pair of worksheets did not get stapled. I was talking while running them through the copying machine and the staple button just didn't get hit. So they're together, but again, you have two worksheets that are non-stapled. So a stapler will be passed around, I apologize. On the back of these worksheets are the solutions. So you have the answers on the back. And you can put your work on worksheet 3-1, the graphing, but the other one, I need your work on a separate piece of paper. So the elimination substitution page, which is 3-2, please put your work on a separate piece of paper. So both of those are together. So stapler is coming around. Again, on the back are the solutions, the even ones for the first page, the odd ones for the second. Please place your work on a separate piece of paper for section 3-2. And then I'll be collecting this on Monday and looking through it and grading it. So 20-ish minutes, grab a partner, get to work, use this time to benefit you. You might be able to get the whole first worksheet done, all of those even problems on the first worksheet. Oh yeah, I didn't do that either, no. And then I will give your test back to you Monday. I'll pass them back probably during homeroom so that you have those chapter 2 tests to look at.